Integration for physics. I will teach you the complete topic of integration. After watching this lecture, you will master integration for physics. Before watching this lecture, you must watch our master class on differentiation and its link is given in the description. First of all, I will teach you some key concepts which will help you to understand integration. The first concept is summation. In mathematics, summation means sum or addition. For example, consider this pattern 1 plus 2 plus 3 plus 4 plus 5. Now to write this pattern in a more clean way, we use sigma notation. I write the sigma symbol. We can see that this pattern starts from 1. I write I is equal to 1. Remember that this I is known as index. It shows us the starting number of a pattern. Secondly, we can see that the last number of this pattern is 5. I write 5 at the top of sigma notation. Lastly, the sum of 1 plus 2 plus 3 plus 4 plus 5 is equal to I. I get this summation is equal to 15. Thus this whole thing means sum of I starts from 1 and goes up to 5. Let me repeat it. Sum of I starts from 1 and goes up to 5. Now consider this pattern and write its sigma notation. Well, I write the sigma. We can see that the pattern starts from 1 and goes up to 100. I write I is equal to 1 and it goes up to 100. Then I write I. Thus it means that the sum of I starts from 1 and goes up to 100. Thirdly, consider this sigma notation and write its pattern. Well, the pattern is xi. I write this x term here. We can see that I starts from 1 and goes up to 10. I write x raised to the power 1 plus x raised to the power 2 plus x raised to the power 3 plus up to x raised to the power 10. Thus this is the pattern of this sigma notation. Finally, consider this sigma notation and write its pattern. Well, the pattern is yn. I write the y term here. We can see that n starts from 1 and goes up to infinity. I write y1 plus y2 plus y3 plus up to y infinity. Thus this is the required pattern. Remember that this is very important pattern and we will use it in integration. Hence noted down this important sigma notation which we will use later in this lecture. Now I will teach you the most important concept of calculus which many talented people are not understanding. For example, consider the earth. Let I select any curved region from it. I zoom in this curved region. As a result, we can see this flat region. From this example, we learned very important lesson. We learned that extremely small part of a curve is flat or straight. Let me repeat it. Extremely small part of a curve is flat or straight. Now we will learn it in mathematical language. For example, consider this curve. Let the length of this curve is x. Now listen carefully. I am interested to cut flat or straight piece from it. To do so, I will put limit on the length of this curve. I write length is equal to limit x approaches to 0. This limit x approaches to 0 means that the length of the curve is so small that it appears flat. Let me repeat it. This limit x approaches to 0 means that the length of the curve is so small that it appears flat. From this example, we learn that a part of a curve becomes flat if you put limit on it, like limit x approaches to 0. Thus this limit x approaches to 0 is the most powerful tool through which we can easily convert any curved path to flat or straight path. Hence note down this important tool which we will use in understanding integration. Now we will learn the basic concept of integration using my personal approach. We know that integration is used to find area under the graph with x-axis. Here, remember that dx means small change in x. Now consider this p-time graph and find its distance. Well, to find distance traveled, we find the area under the graph with x-axis. We can see that the area under the graph is like a rectangle. Let this side is x and this side is y. We know that the area of rectangle is x into y. Thus using this simple method, we can easily find area under the graph that gives us distance traveled. Now consider this graph and find area under the graph. Well, this time there is no proper shape like rectangle or triangle. Hence it was the biggest problem in mathematics. To solve this problem, Newton Baba and Leibniz Baba introduced a new concept. Newton Baba states that we will divide the area under the graph into smaller infinite rectangles plus shaded curves. After that, we will add the area of the infinite rectangles plus area of shaded regions. Let the width of this rectangle is dx and its height is y1. Let the width of this rectangle is dx and its height changes to y2. Let the width of this rectangle is also dx and its height changes to y3. This pattern repeats until it goes to infinite rectangles. Here, the width of all rectangle is the same, which is dx, but their height changes to y1, y2, y3 up to y infinity. Now Newton Baba says that area under the graph of a rectangle is equal to area of first rectangle plus area of second rectangle plus area of third rectangle up to area of infinite rectangle. We can see that area of first rectangle is y1 into dx plus area of second rectangle is y2 into dx plus area of third rectangle is y3 into dx plus up to area of infinite rectangle, which is y infinite into dx. Here dx is common. I write y1 plus y2 plus y3 plus up to y infinity and I take dx as common. We can see that this y1 plus y2 plus y3 up to y infinity is a pattern. We can write this pattern in sigma notation, which we already learned. I write sigma n starts from 1 and goes up to infinity, n to yn and to dx. Remember that this is only the area of rectangles. The area of shaded curves is unknown. Let me repeat it. This is only the area of rectangles. The area of shaded curves is unknown. Now to find the area of shaded curves, Newton Baba takes this rectangle. He states that the width of this rectangle is dx. To eliminate this shaded curve, he puts limit on dx. He writes width of a rectangle is limit dx approaches to 0. As a result, the shaded region or curved region becomes flat. That's why we learned the concept at the start of this lecture. Thus Newton Baba rewrite the sigma notation as total area under the graph is equal to limit dx approaches to 0 sigma n starts from 1 and goes up to infinity and to yn dx. To simplify it further, he writes integral n starts from 1 and goes up to infinity and to yn dx. This is known as integration. Thus, integration is the sum of infinite rectangles to find area under the graph. Let me repeat it. Integration is the sum of infinite rectangles to find area under the graph. Remember that there are two types of integration. Definite integration like this one. Here, the upper and lower values are known. We call this type of integration as definite integration. The second one is indefinite integration like this one. Here, the upper value and lower value are unknown. Hence, we call this type of integration as indefinite integration. Thus, note down this basic concept of integration. Now, I will teach you two of my favorite questions. The first one is, what is the difference between differentiation and integration? Well, we already learned in our previous lecture of differentiation that differentiation finds the instantaneous rate change. For example, in this graph, dy by dx finds instantaneous rate change at a particular point, while we learn that integration finds area under the graph. For example, in this graph, integration finds area under the graph. The second question is, what is the relationship between differentiation and integration? Well, I say there is reverse or anti-relationship between them. I mean, integration is known as antiderivative. Or one can say that the reverse process of differentiation is known as integration. For example, consider a function y is equal to x squared. Its derivative is 2x. Now, if I find the integration of 2x, I will get x squared. Therefore, we say that integration is the reverse process of differentiation. Hence, note down these important questions. Now, I will teach you the super easy trick to find integration of trigonometric ratios. First of all, I write these groups, group 1, group 2 and group 3. In the first group, I write sin x and cos x. In the second group, I write tan x and secant x. In the third group, I write cot x and cosecant x. Now find the derivatives d by dx of these trigonometric ratios. We already learned the trick in our previous lecture of differentiation. Firstly, I put minus sign with all those trigonometric ratios that starts with c, like cos x, cot x and cosecant x. In the first group, I draw these cross lines. Here, the derivative of sin x is cos x and that of cos x is minus sin x. In the second group, I draw these cross lines. I write secant x 2 times because double arrows originate from it. Hence, the derivative of tan x is secant squared x and that of secant x is tan x into secant x. In the third group, I draw these cross lines. Hence, the derivation of cot x is minus cosecant squared x and that of cosecant x is minus cot x into cosecant x. Now let me ask you, find the integration of these trigonometric ratios. Well, I shift the minus sign from the right hand side to the left hand side. Now I put the integral. We know that integration is the reverse process of derivation. Hence, the reverse of cos x is sin x. The reverse of sin x is minus cos x. The reverse of secant squared x is tan x. The reverse of 10x secant x is secant x. The reverse of cosecant squared x is minus cot x. And the reverse of cot x into cosecant x is minus cosecant x. Remember that when we find integration of any function, we put plus c with it. So I put plus c with all of them. Thus by this way, we can easily find the integration of trigonometric ratios. Now we will learn how to calculate indefinite integration. Well, consider this question. The rule of integration is very simple. Write the term as it is. The term is xn. I write it here. Then I add 1 to its power. At last, I take this n plus 1 and I write it in denominator. This is the integration of this question. Remember that n must not be equal to minus 1. If n becomes equal to minus 1, then we cannot use this rule. Hence note down this important point. Now consider these questions and find their integration. In case of the first question, the term is x squared. I write x squared. Then I add plus 1 to its power. At last, I write the power in denominator. I get x to the power 3 upon 3 plus c. In case of second question, this 4 is constant. Remember that we always write constant out of the integral. I write 4 integral x cube dx. I write 4x cube. I add 1 to the power and I shift this power to the denominator. I get 4x raised to the power 4 upon 4. Now this 4 and this 4 cancel out. I get x raised to the power 4 plus c. Hence this is the answer of this question. Now in case of third question, I rewrite this function. We can see that the term is x raised to the power 1 by 2. I take it and I write it here. I add plus 1 to it and I divide this term by its power 1 by 2 plus 1. I get x raised to the power 3 by 2 upon 3 by 2 plus c. Thus this is the answer of this question. In case of fourth question, there are two terms, x cube and 1, and they are separated by positive sign. I write integral x cubed dx plus integral 1 dx. I get x raised to the power 3 plus 1 upon 3 plus 1 plus, remember that the integration of 1 dx is x, while the integration of 0 dx is a constant number like c. Hence the integration of this 1 dx is x. As a result, I get x4 upon 4 plus x. Thus this is the answer of this question. In case of fifth question, there are two terms. I write 5 integral x dx plus integral sine x dx. I write 5 into x raised to the power 1 plus 1 upon 1 plus 1 plus, we know that the integration of sine x is minus cos x. I get 5 upon 2 into x squared minus cos x. Thus this is the answer of this question. Hence note down these basic questions of integration. Now we will learn some difficult questions. Let's consider these questions. We can see that x is present in denominators and its power is 1. Here the power of x is minus 1, so we cannot apply the previous rule. In case of such type of questions, I always teach this easy trick. I write log x and log x. Then I shift the number from numerators and put them as a power of x. Like this one, this 2 and this 5. Hence, these are the values of these questions. Now consider these questions. Here, x is present as a power. In such type of questions, I use the simple trick. I select the base term like a, 2 and 6. Then I write their 1 by log, like 1 by log a, 1 by log 2 and 1 by log b. At last, I write the term as it is, like ax, 2x and 3x. These are the values of these questions. Now consider these questions and find their integration. Well, the integration of ex is the same as ex plus c. In case of second question, this dx means integrate the x term and all other terms are constant. So I write yt integral x into dx. I get yt into x raised to the power 1 plus 1 upon 1 plus 1. I get yt into x squared upon 2. Hence, this is the answer of this question. Therefore, we use this easy method to calculate the indefinite integration. Lastly, we will learn definite integration. For example, consider these questions and find their definite integration. Remember that we call such type of question as definite integration because the lower value and upper value of integration is known. Now in case of first question, I integrate the value of x. I write x raised to the power 1 plus 1 upon 1 plus 1. I put square bracket. Then I write lower limit, which is a, and I write upper limit, which is b. Remember that in case of definite integration, we do not write c. At last, I write the integration of x 2 times, x squared upon 2 and x squared upon 2. I put minus sign in between. Remember that I put upper limit on the first term and I put lower limit on the second term. Now I put the value of upper limit and the value of lower limit instead of x. I get b squared upon 2 and a squared upon 2. Or I get b squared minus a squared upon 2. Hence, this is the answer of this definite integration. In case of second question, the integration of x squared is x 2 plus 1 upon 2 plus 1. I put lower and upper limit. The upper limit is 4 and the lower limit is 1. Now I write this term 2 times. On the first term, I put 4 or upper limit, while on the second term, I put 1 or lower limit. Now I put the values of limit in their respective terms. I get 4 cubed upon 3 minus 1 cubed upon 3. I get 64 upon 3 minus 1 upon 3. Or I get 63 upon 3. After calculation, I get 21. Hence, this is the result of this question. Therefore, using this simple method, we can easily master integration.